This podcast is brought to you by the School of Advanced Study, University of London.
It is very nice to see you all, and we have a double pleasure because we're welcoming Stephen Boyd Davies, our speaker, not only to the Long 18th Century Centre, but to the IHR. So it's a very pleasant moment indeed. Someone from the Royal College of Art, you can no doubt tell us how we could improve our decor.
I wouldn't dare.
And the theme is one on the visualization of time, which is one very dear to my heart as a historian of time, but one that ought to be of great interest to all historians, given that at this moment there is a very interesting return to the long term and the temporal term, so that there's been this immense fixation with space analytically. We're not shedding space, and space is also how we view time, but we are looking to the long-term time. And things like, remarkably, Piketty's book on social and income inequalities, among other things, at the end, has a passionate study of economics and economic historians. That economists should all study economic history. And you're thinking, whoops, I don't know if economic history is quite worthy of this yet, but it ought to be. So there is an interest in the long term, as you probably know, there's now the association of big history, which goes right back to the origins of the cosmos. So thinking about the very long term is something we should be doing as historians anyway. This is what our subject is. But this is a specialisation of Stephen's. As soon as I came across his work, I was immensely attracted and decided he must come and talk to us, so it's a great pleasure. He's here. He's a professor of design research now, having begun as a designer, as a textile designer. He's interested in the visual representation of historical time, the creator of a mobile digital game called ERB Dragons, 2005. I'm sure Tim Hitchcock will know this as our digital man. And in particular interest to me, published in 2013, Human-Centric Chronographia, Making Historical Time Memorable in Human-Centric Visualization. Well, having said that, I say no more. I hand the baton to Stephen.
Thank you very much. Thank you for inviting me. I'm thrilled to be here. I'm very nervous in being in a room full of proper historians because, as you gather, I'm not a proper historian. So if you ask me difficult questions, I'm going to say I'm a designer and hope to get away with it. The questions I want to look at are, why does Priestley's 1765 chart look the way it does? And in the process, to try and discern what Priestley's key contribution was. I'll say something above all about appearances. I'll be concentrating on the look of things, in particular the chart itself, but also looking at the explanations that Priestley and his contemporaries offered for the artifacts they created. Two at least of these are hardly ever referred to. I'm quite unusual in having bothered to seek out and actually read these contemporary explanations by the authors of some of the key diagrams that you'll be seeing this evening. I don't think I probably need to tell most people in this room who Joseph Priestley was, but some of the other characters may be less familiar, and I'm happy to try to answer questions about them afterwards. So, Priestley's 1765 chart maps individual lives on a uniform timescale, and that's important, from 1200 BC to 1800 AD. Possibly for the first time, each life is represented by a single line whose length denotes duration. And we're just going on a tour of the four corners of the chart here. And this is what the chart looks like longitudinally. So here's an overview seen from one end, from Priestley's own time. Each life is assigned to a category, and Priestley confesses that this presented some problems and he had to make some pragmatic choices about which columns to put people in. So, what can we say about it? It's diagrammatic, mechanical, based on a uniform mathematical space. It is, apart from the cartouche that you can see a glimpse of there for the dedication, incredibly plain. So why is it so abstemious, so obviously with hindsight a prototype of modern data visualization, and so devoid of visual rhetoric? I'm going to attempt to trace the story of three traditions and position Priestley's chart in relation to those. I also want to set up an opposition, all designing attempts to make sense of data with a reader or viewer in mind. And in that sense, some people have argued that all design is rhetorical, and certainly I accept that no design is completely neutral. But I also want to explore an opposition between those designs that are intended to form the viewer's opinion in a particular way and those that are intended to leave many options open to support the viewer's independent thought. And I'll suggest that Priestley belongs decisively to that latter category. Here are some of the cast of characters that I'm going to use to set the context. So the first and almost certainly the oldest tradition is that of the list, which subsequently becomes the textual table. And I'm going to cite just two examples from the entire history. Famously, Eusebius is credited with creating an early, perhaps the first, synchronized table of historical events, where both sequence down the page and synchronism across the page can be read at a glance. Much later, Helvetius explicitly argues that equal rows in the table enable the page to become a kind of measure of elapsed time. He assigns equal space to each year, whether there is a little data or a lot, using a regularized grid. So here's the explanation from a later English edition. For every page of his did contain 100 entire years, whence it appeared that there was the space of 100 years between the beginning of the Peloponnesian War and the time wherein the Grecian monarchy began. So you can see that here. Here's the war, and exactly a page lower, if you consider the page to be, as it were, continuous. So we have the start of the Grecian monarchy. So it acts as a kind of measure. We can't really say that this is seeing time diagrammatically, seeing time as space in quite the sense that will emerge later on. Helvetius' influence was still being felt over a century later. Blair particularly praised the uniform, constant spatial scale for time and used it in his own tables that you see here. And we know that Priestley read Blair because he was one of his reference sources for dates. So much for the textual and typographic tradition of the list or table. The second tradition is that of seeking a figurative metaphor for time, a shape, an object, an animal, a body part, a mythological figure. I'm going to, again, absolutely skate over these. I'm relying, as some of you will notice, mainly on illustrations borrowed from Rosenberg and Grafton's wonderful book from 4 years ago on the history of the timeline. Such figurative shapes not only make sense of history by giving it form, they also serve as mnemonics, exploiting the two traditional methods of spatial memory and vivid imagery. Making dates and chronologies memorable has been an ongoing concern. So I'll just let these tell their own story. And so after that lightning romp through the pictorial tradition, we'll also leave the figurative and head towards the diagrammatic. And this third strand will be the one to which Priestley's charts belong, along with those of some important contemporaries. I'll argue that making mechanical, mathematized charts of history is essentially a new idea in the 18th century. It relies on a changing model of the nature of historic time and a perception of its analogy to space. One element, however, of the mechanical tradition goes back a long way. Here's a paper machine for the production of new knowledge from an edition of Lowell's Ars Magna. And Vorwels had a long tradition in making sense of the movement of the planets, tides, and religious festivals, which obviously have some relation to time, if not exactly to history. This idea was adopted and adapted by Christoph Weigel in Nuremberg in the early 18th century. So Weigel took the idea of these, as it were, paper clocks and applied it to chronology. You can see here that the hand of the clock, as it were, simply acts as a permanent reminder of which column or ring you're looking at. It doesn't actually produce new knowledge when combined with the other circle behind it. So what did Weigel think he was doing? He made several of the claims that have become standard for these kinds of visualization. He talks about presenting together on a single sheet all emperors and kings in the European empires, along with the Roman popes, in their correct year order and succession, and so forth, in such a way that one sees in one effortless view which rulers reigned in the same time together. And these will become routine claims for visualization. The idea of an all-encompassing single view, of effortless apprehension, of order and rigor, and also the benefits of the synchronological, the fact that you can see, because it's visual, you can get access to both temporal order and contemporaneous events. Now, going off at an apparent tangent for a moment, I want to introduce two other figures, setting these developments in another context. Descartes' writing shows some relevant ideas, even obsessions. One's the idea of a vivid image, a clear representation. Also the idea of grasping magnitudes at a glance and of line lengths corresponding to number. At one time he even argued that any mathematical relationship must necessarily have a visual counterpart, although it's pretty certain that he abandoned that opinion. And he argued the use of a number line, something we now teach to little children, but was a significant intellectual step at the time. So my argument is that these ways of thinking about number, time, and graphics set the scene for the later developments in chronographics. And Newton argued, of course, the notion of time as a uniform, unvarying container. And perhaps because of his fascination with chronology, we can assume that he saw historic time as essentially similar to clock time, just on a larger scale. It's interesting, incidentally, that there's no evidence that Newton ever made a diagram of historical time. You'll all be very familiar with this famous, perhaps notorious phrase. And you probably also know about Newton's obsession with chronology, on which he claimed to have spent 30 years on and off. Certainly to his contemporaries and immediate successors, chronology was a key part of his contribution. The 4 volumes on which Newton leans in Ruysbrack's memorial are in apparently equal importance. Divinity, the one you can hardly read, you'll have to take my word for it. It says chronology, optics, and Principia. And as well as telling us about Newton, this is a reminder of the huge importance of chronology up until the 18th century. Chronology was seen as giving rigor and sense-making and order to history. Newton's proposition that location in time is analogous to that of space was seen as an exciting new contribution to thought, not least by D'Alembert in his article on chronology for the Great French Encyclopedia. And Priestley is a disciple of Newton in almost every respect. He describes his chart as an ocular demonstration of Newton's chronology. And when he wants to argue the benefits of his chart, he uses Newton as an example of a key figure whom one can see situated amongst his contemporaries. In some ways, the idea that history comprises or depends on the sciences of chronology and geography is a much older one. There was a long tradition of pairing the two, often with the metaphor of the two eyes of history. It's proved really difficult to discover where this particular metaphor came from. I found a side note printed in Purchas's Pilgrimage in the second edition, citing Chytraeus, and that led me to what may be the original source. So here's what seems to be the original of the idea from 1563. Then let students understand that there are two, as it were, eyes of history, the knowledge of places and of times, of topography and chronology. Immediately prior to the 18th century emergence of the charts of history that are my subject this afternoon, lie the eminently covetable visual objects of 16th and 17th century cartography. Objects of learning, but also of admiration. Luxury visual aids. And the power and perhaps the desirability of maps was not lost on my next figure, Martignoni. Here's his attempt to harness the power of geography as a visual analogy to history. It's almost contemporary with Weigel's mechanical Volvel, but I'd suggest that this chart belongs very much in the tradition of rhetorically driven, figurative metaphor. It takes the idea and above all the image of a map as its primary method of making sense. We see the literal centrality of the Roman Empire through which all European history flows. So each region's history enters the time of the empire from above and emerges below. Note that even prior to the encounter with the Roman Empire, the Italian rivers look much more orderly than the German, which are quite wild and woolly. And none of them quite conform to the dictates of time. If time's flowing uniformly downwards, as Martignoni tells us it does in his extremely verbose explication, then time in Italy is standing still, often, and in Germany it's often heading backwards. Here, for instance, if time goes that way, as he assures it does, what is happening? There, you may well ask. So we get a powerful visual rhetorical impression, but it's quite impossible to do some kinds of historical work using this representation because the rhetoric takes over from the data. Note the geographical maps inserted into metaphorical lakes, in metaphorical rivers, in a metaphorical terrain of time. And the actual explication that Martignoni provides is quite confusing at times because he will be talking about the rivers of France and you realise that he actually means the metaphorical temporal rivers, not the real rivers of France. So as a kind of information design metaphor, in a way it's a bit of a car crash, but nevertheless a fascinating and rather beautiful object. Martignoni does make a classic case for the superiority of visualization. He explains how his chart supports three modes of inquiry: inquiry by sequence of events, by century or time, synchronology again, and inquiry by territory or dominion. Here, Germania emerges from the Roman Empire, and the little shields on the perimeter in principle allow us to trace upwards and backwards through time each of the great houses. You can see that most of them are blank, and all of the editions that I've seen images of this particular artifact, editions of it, and none of them seems actually to be complete. It seems to have been an ambitious project which was never fully resolved, never fully completed. I want to turn now in another direction, away from the organic imagery of rivers and terrains to a broader mechanical culture in which I suggest Priestley was operating. Simon Schaffers noted the nice coincidence of Arkwright's spinning frame and Van Campelen's mechanical Turk, two very different celebrations of the machine. It was the time of Jethro Tull's seed drill, which promised to replace the random organic patterns of broadcast seedlings with those of perfectly spaced lines. A visually extraordinary idea. Uniform, repetitive, regular terraces were the future of architecture. Natural watercourses were mechanised through the canal system, with over 1,000 miles of canal built in Britain between 1760 and 1800. And for the first time, personal responsibility for the pavement outside your house was replaced by uniform paving funded through local taxes. But mechanism was contentious. Here are two definitions in use in the 18th century. One is neutral. But the other has a distinctly derogatory tone. And similarly, using a contemporary French dictionary, one again is neutral, but the other is explicitly deprecating. It signifies also noble and low. And I'll only present this tiny fragment of evidence. There is more, but I believe that one can trace an opposition to mechanism from traditionalists and an enthusiasm for it amongst dissenters and radicals. David McCallum's argued in the French context that the whole subject of measurement was politicized, with the Ancien regime identified with arbitrary seigneurial measures, while the impending revolution identified itself with those that are uniform, fair, agreed, and regulated. And here we have Hume standing in as a representative of the more radical dissenting view, where the mechanical arts are seen as equal in importance to the liberal arts. Now, I've got a couple of other key people to visit before I return to Joseph Priestley. Here's the chart that Barbeau de la Bruyère made in the edition that's held by the Municipal Library of Dijon, which very unusually also has a copy of the explanation that Barbeau published. Now, Barbeau would have been familiar with the Abbé Langlet's Table chronologique of 1729, which belonged to the mainstream typographic tradition. In conventional fashion, they organised kingdoms across the page and time downwards. This phrase from the rubric on his chart epitomises Barbeau's different project. I think it's rather appropriate. It sounds a bit like the attributes of a clock or some other machine. Barbeau is explicit about the spaces of time, les espaces du temps. He cites the old saw about the two eyes of history, incorrectly attributing it to Cicero. But in his hands, these are not now metaphorical companions. They are dimensions of a coordinate space. Now, Barbeau certainly knew his maps. He'd worked in Holland among map makers and imported them into France. He lived, apparently, for several years with Philip Gouache, state map maker and half of the map publishing house of Delisle and Gouache. But he uses the spatial measurement and symbolic codes of maps, not their superficial appearance in the way that Martignoni had done. Every change in the extent of each regime at a particular time can be tracked. Unlike using Martignoni's wiggly rivers, here we can do real work tracing individual regimes through time and space. Here's the British Library copy of that same chart. And here's something else they have. This is a rip-off by Jeffries, who describes it as done from the French with considerable improvements, doesn't credit the French originator, and strongly displeased poor old Barbeau. We know that Priestley saw either Barbeau's French chart or this adaptation, as he, Priestley, criticised it on two grounds. One was the attempt to get the two dimensions of geographic space into a single dimension of the chart, although Priestley ended up doing that himself later in his own new chart of history, having originally said that such a thing was a silly idea. And the other is its non-linear timescale, and we'll come back to that. Finally, before returning to Priestley, we touch on one other predecessor, a mutual friend with Priestley of Benjamin Franklin, and their chronographic work was known to each other through Franklin's correspondence. So this is an enormous chart. It's 16.5 meters long, 45 centimeters high. And this author was a keen disciple of the mechanical, but as a way of organising information and as a characterisation of how easy and automatic learning from visualisation would be. Events so strike the senses, organise themselves effortlessly in the memory, imprinted there so strongly that we learn almost automatically, hardly needing to think what we do. Dubourg went so far as to actually build a time machine, underlining the mechanical properties of his design. It used a uniform timescale for all of history since the creation, despite this leading to quite a lot of almost empty pages. So there we have the beginning of time. We've got Adam, Eve, Cain and Abel, and then, as you can see, quite a lot of empty space. And believe me, there's a lot more empty space after that before things start to happen. So the chart's dominated, as usual, by kingdoms and rulers, but one horizontal band is of notable figures. It's essentially similar to Priestley's chart of biography, though with the important difference that there are no number lines used to denote lifespans. The indication of when a person was is simply their name. When Priestley produces his chart that does include lines, he says that he points out very strongly that it's the lines that matter and that the names are labels for the lines. Incidentally, this sort of iconographic language set of symbols here is quite interesting. I don't have time to go into that now, but as you can no doubt guess, it denotes the characteristics, or as it were, the profession of the individuals concerned. And there's also a band for notable events. This copy at Princeton has handmade editions, and Stephen Ferguson, the librarian there, suggests that the choice of events to add may indicate that this was actually Dubourg's own copy of the chart, because they're things that we know he knew about and was interested in. And speaking of machines, I was absolutely thrilled to discover, finding out more about Dubourg, that one of his roles was as the examiner for the degree of Monsieur Guillotin. So yet another connection with machinery. So I've tried to trace the story of three formats and traditions and to begin to position Priestley's chart in relation to them. Here's a reminder of how it looked. So it's a small letterpress book with tipped-in sample engravings printed in Warrington, that part of which is devoted to explaining the chart, part of which is an index to the characters to be found there, and then a large copperplate engraving printed on 2 sheets in London. So at this halfway point, I hope I've shown that the idea of a measurable space for time is part of an increasingly prevalent opinion among his immediate predecessors and contemporaries. The idea of naturalness is a recurrent theme in Priestley's thinking, and it's actually closely allied to the idea of the mechanical and the automatic, whereas for us, I suppose, the words mechanical and natural tend to sound like opposites. For Priestley and many of his contemporaries, information that's organised in the most natural order, such as by time, is apprehended automatically and effortlessly. So, in what remains, I'm going to draw attention to Priestley's key contributions as I see them, and say a bit more about that initial question I started with of why the chart is the way it is. It seems to me that grappling with uncertainty is one of Priestley's most important contributions. It, in some ways, just epitomises his practicality as a teacher. He simply wanted to make clear to what extent any given historical fact is a certainty. But I think it also epitomises his beautiful honesty. Almost all designers of timelines, even now, simplify away such subtleties. Priestley realises that to use a solid line would be to misrepresent, and that a non-existent certainty would be fixed in the mind of the viewer. And so he uses this code of 1, 2, and 3 dots to represent the amount of uncertainty about a date of birth or date of death. Priestley, of course, does make the standard claims that this produces kind of instant learning. But to help answer that question about why the chart looks the way it does, I want to spend a bit of time now thinking about where Priestley's coming from, using these perhaps slightly surprising sources. The whole project of the corruptions of Christianity of Priestley is to remove distortions and especially uncalled for additions from pure facts. The project is to replace mystery with clarity. His proposition is there are some core facts, plain truth and common sense, which are probably seen as essentially the same thing, which must not be obscured by unnecessary accretions. I think it's almost certainly informed by the radical Protestant tradition. Everyone has their own right and an innate ability to apprehend the Word of God without the intervention or interpretation by another. The project calls for studied simplicity over and over again. And Priestley's comments on the lessons of Christ's life and death. These truths are not to be found in any subsequent literature, he says, but in the facts themselves. A famous phrase, the language of the naked facts. If we can get to these, truth will be understood the same by all right-thinking people. the facts themselves necessarily speak without any interpretation. But how do the facts speak? We'll see that Priestley has an answer to that question. I've only read this volume fairly recently, and I've been absolutely fascinated by it. It yielded far more riches than I was expecting, to be honest. Once again, we're in familiar Priestley territory here. Truth is absolute. Any rhetorical trickery that's not in the service of truth is equivalent to poison. No frills, again. To inform effectively is in itself to produce the desired behaviour in the audience, to inform the judgment and thereby direct the practice. And everyone is susceptible to perceiving the same truths. Now, many of you will know that Priestley was fascinated by Hartley's theory of the association of ideas, which both interpreted in a strictly mechanical, mechanistic sense. And the natural mechanical nature of association is both a powerful aid, but also a potential pitfall. So Priestley's talking here about how bad associations of ideas are as powerful as desirable ones. And we saw how he didn't want a solid line to evoke a visual lie. Natural, automatic, mechanical reactions to things are irresistible and cannot be overpowered by reasoning. This takes place instantaneously and mechanically. No person whatever hath reflection and presence of mind enough to be upon his guard against some of the most useless and ridiculous effects of it. Priestley acknowledges that each person's associations are different, so we bring to any particular stimulus our own set of associations. But I think Priestley therefore goes on to think that although each of us takes away a potentially different message from the same percept, there'll come a day when the whole world has been so mutually influenced that everyone's associations will effectively be the same. And before leaving Priestley's other writings, I want to briefly touch on one more example of his exaltation of mechanism. Here's Priestley talking about another of his designs, which you'll see in a moment. I venture to say that by the help of such a mechanical contrivance as this, a person of a very moderate capacity or critical skill will have an advantage over a person of the greatest genius and comprehension of mind without it. That may remind you of something you've read elsewhere. Swift's ridicule. The most ignorant person at a reasonable charge and with a little bodily labour may write books in philosophy, poetry, etc., without the least assistance from genius or study, using a machine. Priestley doesn't seem to mind that his argument closely resembles the one ridiculing mechanism that Swift had made. And we do know that Priestley had read that very passage because he mentions it in the Oratory and Criticism. So Priestley attributes what he regards as the success of the design you're about to see to mechanical methods. And those mechanical methods were designed to solve a recurrent problem in biblical studies, that the accounts of the four Gospels don't quite seem to match, and it's very difficult to work out what their unifying chronology is. So his approach to that was a very simple, practical one. He went and bought 2 New Testaments, cut them up, and then rearranged each of the verses and chapters, keeping them all in the, I think, I haven't checked, probably keeping them all in their own sequence, but trying to line them up so that we'd be able to see when the same event was described by 1, 2, 3, or 4 gospel writers. And you can see that in some cases only one has an account. So you end up with this very large amount of white space. Incidentally, something I'm not going to talk about this evening, but I'll just flag it as a potential question, is the price of paper. Because if you think of a 17th century book with its dense print and its tiny margins, when paper was an incredibly valuable commodity, and then you think of the lavish use of paper in the 18th century, think of Barbot Dubourg with his 16.5 metre long chart, large areas of which had nothing printed on them to speak of. Then there's probably a material facilitation of that. But my attempts to research the price of paper have been frustrated. Everything leads back to a tiny number of sources, as far as I've been able to discover. There's a really important project for somebody to fund there, is to find out what was happening to the price and affordability of paper in the 18th century, or indeed many other times. So despite Priestley's enthusiasm for the mechanical and the automatic, we've seen that he feared its dangers. And we're going to glance back briefly at that chart of history that Priestley was so critical of. And I said that one of the things he disliked about it was that instead of in his own chart, at the beginning here he's talking about his own chart, so the chart of biography, my chart, Priestley's chart, uses a constant time scale, whereas several are used in that of history, the French chart. The consequence of which is that in comparing intervals of time in different parts of that chart, the imagination is necessarily imposed upon. Even the notice which is given of this change is not sufficient to correct the error of the imagination, which is impressed mechanically by the view of the spaces as they are laid down in the chart. And this is specifically what he's complaining about. You can use logical thought to understand the 4 different timescales used in the French chart, but by that time it's too late. An accidental assumption of uniform timescales being automatically impressed upon the mind in Priestley's view. And of all the authors I've discussed, Priestley actually is the only one to be circumspect about the dangers of visualization. The others' explanations read a little bit like sales pitches throughout, and some of Priestley's does, but again, coming back to that honesty of Priestley's, he's really keen to talk about the difficulties that visualization, when it's done wrong, may pose. And finally, to conclude, here Priestley makes another of his very special observations. The thin and void places in the chart are in fact not less instructive than the most crowded, giving us an idea of the great interruptions of science and the intervals at which it has flourished. So it's a powerful case for visualization, and again, perhaps the first time this point had ever been made. That mechanical mapping to a uniform timescale had shown up some yawning voids in the data. Priestley realized that this wasn't a problem, it was valuable information.